Okay, so good morning, or today we're going to continue with exercise 2. Right, so chapter 9, exercise 2, we're still looking at the simple harmonic motions. And today we're going to focus more on how to use the equations that I asked you guys to copy last week. Okay, the one in the table.
Morning, madam.
Okay, right, so now let's see. A large mortar in a factory causes the floor to vibrate at a frequency, so you are given F. So always remember, when it comes to chapter 9, if you are given F, it means, well, it either needs you to calculate the omega or it needs you to calculate the period. Okay, because F, omega, and period, they are one family. Always keep that in your mind. So the amplitude of the motions near the motor is about 3 mm. So you are given A in terms of mm. Estimate the maximum acceleration of the floor near the motor. So how to solve these questions? Basically, it's very simple. So you want to calculate maximum accelerations. Therefore, we go for the equations for A max. So according to the table that I gave you in a previous class, A max is equals to omega square A. Right? You need omega, you need A. And you're going to calculate accelerations. So first of all, we don't have omega, but then we do have frequency. So F equals to 10 hertz. From here, we can then determine the omega, where omega is equals to 2 pi F. Okay, so it is equals to 20 pi radian per second. So now you have it in a radian per second, but A is in terms of mm. So if we want to calculate the accelerations, usually we want it in terms of SI unit. So A is equals to 3 times 10 to the power of negative 3 meter. We change it into SI unit. So now we can plug it into the equations. So 20 pi square and then A, which is 3 times 10 to the power of negative 3. So remember to put a bracket in your 20 pi, because quite often students, they forgot about this bracket, okay, and then they just put the square on pi. So basically you have to square both things. 20 you have to square it, pi you also have to square it. All right, so make sure you have to put a bracket here as a reminder for yourself. So without bracket, quite often students will make a careless mistake in the exam. All right, they just square the pi without squaring the 20. So if everything is correct, then eventually you will obtain 11.84 meter per second square. All right, so 11.84 ms negative 2. So that is the answer for questions 1. Very simple. Okay, you're looking at a maximum acceleration, and we have just one equations, which is omega square A. So omega, we can calculate it from frequency. A, we are given the value 3 mm, just that we change it into meter. Right. So I give you 1 minute to write it down before we proceed to next questions. Okay, so this is a very simple questions. Okay, next. Questions number 2. Now, this is a typical exam questions where you are given an equations, and then it gives you a several sub questions that ask you to solve it based on the equations given. So the displacement x of a particles undergoing linear simple harmonic motion is given by x equals to 5 sine 20 pi t, where x and t, they are being measured in cm, and then and second for t. Okay, so what are you going to do now? Whenever you're given an equations, always remember to compare it with general equations. So this is an equations without initial phase angle. Therefore, we compare it with x equals to a sine omega t. Okay, x equals to a sine omega t. This is the general equations. So by comparison, what is the information that you can get? So if you compare these two equations, for instance, you're going to obtain A is equals to 5 cm. So how do I know that the 5 is in terms of cm? Because question tells you x is in cm. Okay, so X and A, they share the same unit. And then so by comparisons, again, I have omega equals to 20 pi radian per second. Okay, so I know it's radian per second because my t is in terms of second. Okay, so if t is in terms of minute, then omega would be radian per minute. So now I have A, I have omega. So the question is asking for maximum speed. So what is the equations for maximum speed? Well, again, we have the equations already. So V max is equals to A omega. Okay, V max equals to A omega, which is then equals to my A is 5 cm. Of course, you can change it to 5 meter. Okay, and sometimes indeed you need 5 meter, 5 meter plus 5 cm in terms of meter. So 5 cm is up to you whether you want to leave it in terms of cm or you want to convert it into meter, okay, which is 0.05 meter. Both are correct. So let's see. If I keep it in cm, then I have a 5 times 20 pi. Okay, 20 pi, which is then equals to 100 pi. So 100 pi at the same time, it is equals to 314. Okay, now what is the unit for this 314? You go back to the unit for A and omega. Okay, so now in my calculations, my A, my amplitude is in terms of cm, and then this one is radian per second. Okay, radian per second. So usually we don't keep radian in our final answer for velocity, for acceleration, and so on. All right, we just write the S. So A is in terms of cm, which means now my V would be cm as -1. All right. So don't always thought that the unit must be m as -1. If your amplitude is in terms of cm, then V would be in terms of cm as well. All right, cm as -1. Questions B. Determines the magnitudes of velocity and accelerations when the particle is at 3 cm from its equilibrium position. Okay, now if you look at the questions, you are given 3 cm from equilibrium position. Now, what does it mean? This statement, it tells you that your x is equals to 3 cm, the displacement. Okay, the displacement is in cm. And question is asking for V and A, okay, with displacement in it. So you are going to search for the equations where V and A, they consist of X in the equations, all right? Meaning that you cannot use the equations with T. You cannot use the trigo functions because there's no X in the equations. So the equations that we need to use to determine the V, okay, is V equals to omega square root A square minus X squared. So this is V with X in it. Okay, the equation's V with X in it. So I can skip the plus minus sign in this calculation, in these questions. Why? Because question is just asking for magnitude. So if question is just asking for magnitude, it means that you can ignore the sign convention in your calculation, all right? So V equals to omega square root A square minus X squared. So which is then equals to 20 pi, okay, 20 pi, and then square root A given is 5, 5 square minus 3 squared. Okay, so again, they are all in cm. Therefore, if you calculate it correctly, you're going to obtain V equals to 215 cm as -1. Okay, so you are given displacement, so you use equations with displacement. So V is equals to omega square root A square minus X squared. Whereas for acceleration, okay, accelerations in terms of X, okay, equations A in terms of X is a omega square X. Therefore, it is equals to 20 pi square times X. So X given is 3 cm times 3. So eventually you will obtain 1.18 times 10 to the power of 4 cm as -2. So it's very simple. You look at the questions. If question give you displacement, then you use equation with displacement. If questions give you times, then you use equations with time. All right, we will go through the equations with times after this in questions 3, if I'm not mistaken. So don't worry, okay? I will show you one by one. Okay, next. Right, so we are done with questions B. And then question C. Determine the initial speed when the particles start to undergo simple harmonic motion. So it want initial speed. So initial speed, we don't know where is the initial position, right? But what we do know, when we talk about initial, usually it refers to times t equals to 0 second. Okay, we don't have initial displacement. But what we do know is initial happens at t equals to 0. So now you are given time. So if you are given times, what are you going to do then? Go back to the equations above. So you are given x equals to 5 sine 20 pi t. So this is the equations in terms of x, the equations of displacement. We don't have equations for velocity. But what we do know is v is equals to dx over dt. That's why I told you in the previous sections that you need to know how to do differentiations. Because quite often you have to do a differentiate in your a solution in your exam. So v equals to dx over dt. We have x equals to 5 sine 20 pi t. So d over dt, now we want to differentiate. Okay, differentiate the equations. 5 sine 20 pi t. Okay, you want to differentiate it. Now, sometimes students, they cannot do differentiations with value. Okay, they are so confused. Now I have value. What am I going to do? Well, in that case, what you can do, you can use the general equations. So your x is in terms of sine without initial phase angles. Therefore, okay, our general equation is x equals to a sine omega t. So you can differentiate these general equations and then you plug in the value. So v is equals to d over dt a sine omega t. All right, so if you cannot differentiate equations with value, then you differentiate the general equation. Now let's go back to the equations with value. So d over dt 5 sine 20 pi t, okay, we take 5 out because 5 has nothing to do with time. So 5d over dt sine 20 pi t, all right? So which then we have 5 times, okay, times the value in front of t. So that is how you differentiate if you are given some value. So 5 times 20 pi, differentiate sign, it gives you cos. Okay, so we have cos 20 pi t. I put the bracket at the wrong place. Wait, yeah. So 20 pi t, close the bracket. So this is your equations, the equations that you obtain after you derive it, after you differentiate it. So which is then equals to 100 pi cos 20 pi t. Right? So if you differentiate your general equations, basically you are just going to obtain v equals to a omega cos omega t. So once you have this general equation, you can then plug in the value for a and omega. Therefore, you can still obtain v equals to 5 times 20 pi and then cos 20 pi t. Right. Okay, so you're still going to get the same equation, all right? Just that what you have to do, you substitute the value after you differentiate the general equations. So eventually you will still get 100 pi cos 20 pi t, all right? So same result, okay, same outcome. So it's up to you whether you want to differentiate the one with value straight away or you want to differentiate general equations and then you substitute the value. Okay, now you obtain this value. What are you going to do next? Well, question tells you initial speed. So what we know is t is now equals to 0 second. So when t equals to 0 second, my v is equals to 100 pi cos 20 pi times t, which is a 0. Okay, which is 0. So cos 0 give you 1, therefore v is straight away equals to 100 pi. Okay, and again, 100 pi is equals to 314.16. Okay, 314.16. So 16 cm as -1. All right, so I know it's as cm as -1 because of my A. My A is still in terms of cm. Okay, I begin with 5. It is in terms of cm. Therefore, my final unit is in terms of cm. So that is the answer for question number 2. Okay, that is the answer for question number 2. So now I give you some time to write it down. Right, wait, yeah. Right. So I give you some time to write it down. Okay, I give you maybe 3 minutes because you got 3 sub questions to write it down. So write down everything, put the notes there, see when to use which equations. Okay, see when to use which equations. Okay, so make sure you understand. Yeah, questions B, it shows you when you have to use equations with x. Question C, it tells you when to use equations with time. So it is when you are given time. Okay, you are given t equals to 0. Therefore, for question C, you use equations with time in it. Okay, so let us move on to the next questions. Okay, so this is another types of exam questions where you yourself have to form the equation for x first. Oops. Ah, okay. So now let's see. Questions number 3. Okay, questions number 3. The particles undergo simple harmonic motions with a period of 0.4 second. So we have period, that is your capital letter T. Okay, your capital letter T with an amplitude 5 mm. So its displacement is at its displacement at t equals to 0 is 0. Now, this statement is very important. Okay, this statement is very important because it tells you what is the initial phase angle. Okay, what is the initial phase angle? So we can use it to determine the initial phase angle for our equations after this. So, and after that, it moved to the right. Okay, so the right-hand side is always a positive in our oscillation. So A determine the displacement of particles at times t equals to 0.15 second. Now you're given times, what does it mean? It means you need equations with time. Okay, equations with t. So equations with t for x, well, you need to form the equations because you are not given the equations. Now let us begin with forming equations. So the general equation is x equals to a sine omega t plus phi. Okay, because we don't know whether there's initial phase angle or not. That's why we need to keep it in our general equation. So once we know, okay, if we don't have it, then we can straight away ignore it. But right now, if the question asks you to form equations, okay, you have to assume you don't know what is the initial phase angle. Okay, you have to find it. So x equals to a sine omega t plus phi. Given a, okay, questions give us a is equals to 5 mm, but then questions give us period. We don't have omega. So always remember, okay, t, f, and omega, they are one family. So from here, okay, we have t equals to 0.4 second. So from here, we can then determine omega. Omega equals to 2 pi over t. Okay, omega equals to 2 pi over t. Therefore, okay, therefore we have 2 pi over 0.4, which is then equals to 5 pi radian per second. Okay, 5 pi radian per second. So according to the highlighted statement, its displacement at t equals to 0 is 0. So it tells you when t equals to 0, x is equals to 0. Okay, so now what am I going to do? I'm going to plug in this 4 value into my equations, okay, to find out what is the value, for my initial phase angle. So x equals to 0 equals to 5 sine omega is 5 pi, and then t given, well, is 0 plus phi. Okay, so from here I rearrange the equations. Eventually I obtain phi is equals to 0 radian, which means now my object is start to move from its equilibrium position. Okay, the initial phase angle, the place where we start to record the simple harmonic motion, is the equilibrium position. It start from equilibrium position. So phi is equals to 0 radian. Now that we have phi is equals to 0 radian, we can then proceed to forming general equation. Okay, forming an equations for our questions. So x equals to a sine omega t plus phi. So x, we keep it as unknown, equals to a is 5 sine omega is 5 pi, and then t, we leave it at unknown. So this is the answer. Okay, this is the equation. This is the equations that we're going to use for questions 1. Equation for displacement. So x equals to 5 sine 5 pi t. According to the questions, okay, now your t is equals to 0.15 second. So what is the x? So x is then equals to 5 sine 5 pi times 0.15, right? So x is equals to 3.54 mm. So you start from forming equation, and then from the equations that you form, you then determine the displacement at a given time. All right? So this is the final answer. So that is how you solve questions 1. Right? It's a slightly more complicated in this question because you are not given the equation. You yourself have to form the equations. So that part, it takes a bit of a step, a bit of times to do it. Right? So x is equals to 5 sine 5 pi t. From there, we then get a value for x, which is equals to 3.54 mm. So again, remember your calculator should be in mode radian. All right, should be in mode radian. Okay, so let's see. Next question. Well, before I proceed to next questions, I give you 2 minutes to write it down first. Okay, make sure you understand this one first. 2 minit bagi anda catat. Kalau dah okay, then we can proceed to the next questions. If you are done, then you can look at the next question first, yeah? Because next question is similar to the previous questions, where you have to determine velocity at a given time. Okay, so if you are done with questions 1, you may proceed to questions 2. Okay, pastikan anda faham soalan 1, okay? Because that is the most fundamental type questions in this chapter. Forming equations. Okay. So now let's look at questions B. Okay, let's look at questions B. Questions B determines the velocity of particle as time t. Again, you are given time. So whenever you are given times, you need to use equations with time. Okay, equations with t. So now let's see. Well, I don't have equations. Again, I don't have equations. What am I going to do? I'm going to differentiate x. So given x equals to 5 sine 5 pi t. So I'm going to differentiate this equation. So v equals to dx over dt, which is equals to d over dt, okay, 5 sine 5 pi t. So I differentiate it. What am I going to get? I will get 5 times 5 pi, and then times with sine cos. Okay, cos 5 pi t. So differentiate sine, you obtain cos. So it is equals to 25 pi cos 5 pi t. So that is the equation for V. Okay, the equations for V. So from here, we can then determine the velocity at times t equals to 0.15 second. Okay, so at t equals to 0.15 second, my V is equals to 25 pi cos 5 pi times 0.15. All right, so you press the calculator, you will then obtain negative 55.54 mm as negative 1. So that is the answer, right? That is the answer. So once you know, you have an idea on how to solve this type of questions, actually it's very simple. So question C. Question C, now it asks you to determine accelerations at times t equals to 0.15 second. Again, you are given time. Whenever you are given times, you use equations with time. Okay, so equations with time, again, we don't have the equations. But what we do have right now, we have V equals to 25 pi cos 5 pi t. So from here, we can then form an equations for acceleration. So A is equals to dv over dt, according to the definition. So it is then equals to d over dt, bracket, 25 pi cos 5 pi t. Okay. And then I'm going to differentiate it. I will then obtain 25 pi times with 5 pi. Now, you differentiate cos, you will get negative sine. So cos become negative sine 5 pi t. Okay, which is then equals to negative 125 pi square sine 5 pi t. So this is how I differentiate it. And again, now because you are given time t equals to 0.15 second, so at t equals to 0.15 second, my A is equals to negative 125 pi square sine, okay, and then 5 pi times 0.15. which is then equals to negative 872.35 mm as negative 2. Okay, mm as negative 2 now. So this is how you solve it. All right, this is how you solve it. Very simple. So again, I give you 2 minutes to write down the answer for questions B and C before we proceed to questions D. Now, question D is very simple. If you know how to do it, then you can solve it first. Okay, you can do it first. So 2 minit bagi anda catat B dengan C. Okay, kalau ada apa yang tak faham, kamu tanya.
Madam,
Yep.
kalau saya tengok yang notas semalam,
Mm-hmm.
notas semalam 2 hari lepas,
Uh-huh.
dia punya negatif sin tu, dia yang kan dekat C, negatif sin ke negatif 25?
Negative sign sebab anda differentiate cost. Differentiate cost kamu dapat negative sign. Tapi sebab dia di depan sign, that's why kamu boleh letakkan dia di depan negative 25. Tak ada masalah.
Okey, cuba tengok nota balik lah.
Sebab nota kamu differentiate simbol sahaja. Kalau simbol, anda memang tak boleh nampak dia punya lokasi dengan tepat. Tapi yang tepat punya, bila anda differentiate cost, anda dapat sign, a negative sign. Okay, so dia punya sequence begini. Okay. So kalau kamu bermula dari sin, you differentiate sin theta, you will get cos theta. Okay, but when you differentiate cos theta, you obtain negative sin theta. So that's why bila kamu ada cos dalam velocity, differentiate dia jadi negative sin di dalam A.
Okey.
Okay, next questions. So questions D, very simple. Okay, questions D, now you are given, okay, the displacement. Okay, you are given X. So you need equations with X because now you are given X. Okay, so this negative 0.2 mm is a X. Okay, negative 2.0 mm. So determine the velocity when the particles is negative 2 mm from equilibrium position. Therefore, I have V equals to, now, this question asks you to determine velocity. Velocity is a vector quantity, so you need to take into consideration the direction. So which means you need to keep the sign conventions now. V equals to plus minus omega square root A square minus X square. Okay, which is then equals to plus minus. Okay, so this is a 5 pi square root. My A is A is 5. Okay, so 5 square minus negative 2 square. Right? 5 square minus negative 2 square. So I will obtain plus minus 72 mm as negative 1. So you need to keep the plus minus sign. So whether it is positive or negative, I don't know. Why? Well, for example, now you have a pendulum. So this is its equilibrium position. Okay, so now your object is located at here. All right, it's located at here. which is a 2 mm from equilibrium position. So this is a negative 2 mm. But I don't know whether it is swinging to the left or to the right. I don't know whether it is heading towards the amplitude or it is heading back to the equilibrium position. Therefore, I cannot choose the sign convention. I cannot tell you whether the V is now positive or negative. That's why I need to keep both of them in my answer. Okay, because there are two possibilities. Either it's moving to the left or it's moving to the right. Depends on the motion. The question just tells me the position without telling me the direction. Therefore, I don't know whether it's positive or negative. Okay, so you keep the sign conventions in your calculation. So V is equal to plus minus 72 mm as negative 1. Okay, mm. So 1 minute for you to write it down. Then we will proceed to next question. Next questions, we're going to look at energy. Okay, we're going to see how to calculate energy. Okay. So this is just a very simple equations, the simple questions, just that I wanted to take note with the sign convention. Okay, you have velocity. Velocity, you need to take into consideration the direction. Therefore, you keep the sign there. Now, let's look at questions 4. Questions 4, a 1.15 kg mass oscillates according to equations. So now you are given equations, and if you notice, now you are given equations in terms of cost. Okay, in terms of cost, which means now what are you going to do? You're going to compare the equations with x equals to a cos omega t, right? So you are given equations with cos, so the general equations, you tweak it a bit to make it become cos function. So x equals to a cos omega t. So by comparisons, we then obtain the amplitude A is equals to 0.65. Okay, 0.65 meter. Why? Because questions tells you now your x is in meter and time is in second. So A is equals to 0.65 meter. And then the frequency. Now, frequency, how to calculate it? Well, I have omega. When I have omega, problem solved. So from omega equals to 7.4. Okay, 7.4 radian per second. Now you don't have pi in your equations. Be careful. Okay, now omega is without pi. So omega is equals to 7.4 radian per second. So we know omega equals to 2 pi f. Rearrange the equations. F is equals to omega over 2 pi, which is then equals to 7.4 over 2 pi, which is equals to 1.178 hertz. So that is the answer for questions B. Okay, so you see, by comparisons, you can solve so many questions already. Next, the total energy. So total energy is E. So how are we going to calculate total energy? Well, we have just one equations, which is E equals to 1 over 2 and then m omega square A squared. Okay, I cannot use the equations with K because now I don't have the spring constant. I don't have the K in the equations. So I choose the equations with omega in it because I have omega in my questions. So E equals to 1 over 2m omega square A square, which is then equals to 1 over 2. Now given m is 1.15 kg. And then omega is a 7.4 square and A is a 0.65. Okay, 0.65 square. So it is equals to 13.303 joule. Now, these questions, you have to be careful, okay, because you are going to calculate energy. Energy, the unit is in terms of joule, okay? So joule is SI unit. So make sure your A is in SI unit. So this question is being very nice to you. It gives you A in meter already. If not, you yourself have to remember to convert it into SI unit. okay, because your unit for energy is joule. Joule is SI unit, which means A, omega, and M, all three quantity, all three variables, they must all in SI unit. Okay, now questions D. Okay, questions D, the kinetic energy and the potential energy when X. So now you are given X. So which means the equations that we're going to use is equations with X. So for kinetic energy, the equations with X is K equals to 1 over 2 m omega square A square minus X square. Okay, so this is the equations. Whereas for potential energy, U is equals to 1 over 2 m omega square X square. Right, so you need to use equations with X. So now let us plug in the value. Okay, let us plug in the value. So K is now equals to 1 over 2. My M is a 1.15 omega 7.4 square. A given is a 0.65 square minus X 0.26 square. Okay, the question's got a mistake, yeah, because they left out, they missed out the unit. The unit for X is meter, 0.260 meter. So plug in the value, press your calculator, you will get K is equals to 11.175 joule. Okay, 11.175 joule. So for U, okay, it is equals to 1 over 2, 1.15, 7.4 square. Now my X 0.26 square. Okay, 0.26 square. So U is then equals to 2.129 joule. Right, 2.129 joule. Now for these two questions, okay, for questions C and D, okay, actually it gives you another set of solution. Okay, you can use another method to calculate either potential energy or kinetic energy. So for example now, after you obtain kinetic energy, you can actually apply E equals to K plus U. Okay, and from here we know U is equals to E minus K. Okay, E minus K. So rearrange the equations, use then equals to E minus K. So if you already calculated K and you got an E from previous question, so this one is actually just equals to 13.303 minus 11.175. Also can, okay, nothing's wrong with it. So a 2.13 joule. All right, 2.13 joule. So nothing wrong. You can use this method to solve it. Okay, you can use this method to solve it. Or if you calculate U first, then you can still use the same equation. E equals to K plus U. K equals to E minus U, which is equals to 13.303 minus 2.129 joule, okay, which is then equals to 11.174 joule. Also can. All right, so it's up to you which combo you want to use, okay? You want to use this combo, this two combo, or this combo also can. All right, it is totally up to you. So I give you some time to write it down. Okay, so for questions A, B, C, D, so we got 4 questions. I give you 4 minutes to write it down. Right, so for questions D, write down all solution, all method, because sometimes you might need to use it. Right, if you are not given enough information, you might need to use the solutions in green color to solve it. So make sure you know, yeah, make sure you know. So if you are done with these questions, actually you can try questions number 5. Questions number 5 is very similar to this question. Okay, so sekarang kamu catat dulu soalan D terpulang pada Anda nak guna combo mana. Okay, nak guna combo dalam biru ke, atau K dengan E dalam hijau, atau U dengan E dalam hijau. Alright, so terpulang pada Anda. Nak guna combo mana satu. Semua cara betul. Okay, semua cara diterima dalam exam Anda. So don't worry about that. Okay, so this is a very, very simple questions. So the important thing in this question is I want to show you how to calculate energy, especially for questions D. So you have more than one method to solve it. Okay, so let us move on to the last question. Yeah. So last questions 5. Okay. An object of mass, so you have m 0.3 kg, executes linear simple harmonic motions on a smooth horizontal surface at a frequency, okay, with an amplitude. So now what are you going to do? You look at the information that you have. Okay, you have m, you have a, you have frequency. Question is asking for energy again. So energy, we know E is equals to 1 over 2 m omega square a square. Look at the questions. We do have m 0.3 kg in terms of SI unit. And now we have A 5 cm. Now we cannot keep it in cm. We need to change it into meter. Okay, because energy joule, this is SI unit. Right? So 5 cm is equals to 0.05 meter. And then we have frequency. Now frequency, well, we don't need it in our solution, in our questions. What we do need is omega. Okay, so omega can be obtained from frequency, where omega is equals to 2 pi f, okay, which is then equals to 2 pi times 10 hertz. So omega is equals to 20 pi radian per second. Okay, 20 pi radian per second. So this is the informations that we have. So now we can calculate E. So E is then equals to 1 over 2 0.3 times 20 pi squared. Remember to put the bracket for the whole omega, and then times with the A, which is 0.05 squared. So E is equals to 1.48 joule. All right, 1.48 joule. So questions B, okay? Questions B, the potential energy and the kinetic energy when object is at 3 cm. So again, you are given X. So you need equations with X. So basically, you can use the methods that I showed you in questions 4 to solve it. So it's up to you whether you want to calculate potential energy first or kinetic energy first. So in your books, okay, they actually ask you to calculate, well, either one actually can. All right, so again, we're going to do both. Okay, so let's start from potential energy. So U equals to 1 over 2 m omega square x squared. All right, which is then equals to 1 over 2 0.3 20 pi square, and then x given 3 cm is 0.03 meter. Okay, which then obtain U 0.53 joule. Okay, so if you have 0.53 joule, the shortcut that you can use is actually E equals to U plus K. K equals to E minus U, which is then equals to 1.48 minus 0.53, okay, which then give you K equals to 0.95 joule, right? This is if you calculate U first. So if you want to calculate K first, K equals to 1 over 2 m omega square a square minus x square, which is then equals to 1 over 2 0.3 20 pi square. A is a 0.05 square minus 0.03 square. Okay, which is then equals to 0.95 joule. So from here, you can use E equals to U plus K, U equals to E minus K, okay, which is then equals to 1.48 minus 0.95 joule. Therefore, U is equals to 0.53 joule. Also can. Okay, also can. Or you want to apply the equations for both of them. Okay, you want to solve it by using these two equations. Also can. So again, you have three combo in questions B. Okay, same as previous question, 3 combo, right? So, well, with this, that marks the end for today's class. Okay, we are done with all 5 questions and we don't have enough time to discuss the next subtopic. So I will stop right here. If you have any questions, you may ask. If no, once you finish write it down, okay, once you write down everything, then you may leave the class.